Okay, students, this is STAAR test review. Number 1, if y equals negative 3/4 x plus 4, what is the slope of a line perpendicular? All right. This is the key phrase here, perpendicular. If we have a slope, and we call that slope m, the perpendicular slope, okay, the one that's perpendicular to that slope, is negative m raised to the negative 1. That's called the negative reciprocal. Negative reciprocal. All right, that's what we refer to it as. But in practice, you just take the slope and you flip it, and then you change the sign. So you flip the slope and change its sign. Let's do that. So our given m in this problem, if y equals mx plus b, then the m position is held by negative 3/4. So m equals negative 3/4. If m is negative 3/4, what is the negative reciprocal of m? Well, the negative reciprocal of negative 3/4, let's flip it first. First we're going to flip it, and we get negative 4/3. Okay, so now we got to change the sign. Change that negative to a positive. So the negative reciprocal is equal to 4/3. And that is the slope of a line that is perpendicular to the one that you were given. Positive 4/3. Put it in a box. Now, number 2, what is the y-intercept of this graph? Well, whoever created this test review did not label the axes, so we better label them. The vertical axis is y, and the horizontal axis is x. And that turns out to be important because we want to know what the x-intercept is. So the relevant part here is x. I want to know the x-intercept, and that's right there, negative 3. So what we'll write is the x-intercept, which we can abbreviate x-int, equals, and rather than just writing negative 3, let's write the coordinates of this point. All right, so when x is negative 3, y is 0. So I'll write negative 3, comma, 0, just like that. I write it that way because it's x, comma, y. So I've got to put the x there, and the y is 0 when x is negative 3. Just for fun, what's the y-intercept? This isn't asked for, but the y-int, the coordinates of the y-intercept are 0, comma, negative 1. So when you're looking for the x-intercept, y is always 0. When you're looking for the y-intercept, x is always 0. Just an interesting observation. This is your answer. Number 3, is this a function? Well, the definition of a function is somewhat complex, but one of its parameters is that the x values can never repeat. So we have to make sure that none of these are the same. Now just a cursory glance, that is my first glance through, none of them look the same. But on a second pass through, I notice I've got a 3.5 and a 7/2. Now the problem is I don't know if those are the same or if they're different, because one of them is using a decimal form and one of them is using a fraction form. So I either have to turn the decimal into a fraction or the fraction into a decimal before I can really compare them. And we're going to show it both ways. So here is 3.5, and we're going to turn that into a fraction. So 3.5 can be rewritten as 3 1/2. And 3 1/2, the way you convert it to a fraction is you multiply the denominator by the whole number, and then you add the numerator. So what that looks like is 3 times 2 plus 1 over 2. And that equals 7 over 2. No one really writes this step out. You just do it in your head. You're like, well, 3 1/2. So 2 times 3 is 6. 6 plus 1 is 7. The answer is 7 over 2. So right away, I've got a problem. And the problem is that 7 over 2 was 3.5 as a fraction, and I already see it listed. So I'm seeing the x values repeating. So it cannot be a function. The actual answer to this question is no. And here's why, right? Like, this is why. And you need to tell me why. It's like, so let's convert 7/2 to a decimal. So if you had started from the other direction, 7/2. So what we would do is we would take 7 and divide by 2, kind of like longhand division. And 2 goes into 7 3 times. 3 times 2 is 6, right? And so we're going to subtract. 7 minus 6 is 1. We put a decimal, and then we drop down this 0. And we say 2 goes into 10 5 times, 3.5. So I got 7 over 2 equals 3.5. In other words, 3.5 equals 7 over 2. So because of this reason, this cannot be a function. No. It cannot be a function because these x values repeat. Number 4, sketch and shade 2x minus y less than or equal to 4. So we're going to show work over here. Before I do anything, I have to get y by itself. Get y by itself. So I've got 2x minus y is less than or equal to 4. And I want to solve for y. Now, the first step in this process is to subtract 2x from both sides. Okay, cancels out on the left, and on the left-hand side I've got negative y less than or equal to, and remember we always put the x term up front, negative 2x plus 4. Now I need to get rid of that negative in front of the y. And when I do that, I will be multiplying or dividing everything by a negative number, so I'll have to flip that sign. Because when you multiply or divide an inequality by a negative number, you have to flip the sign. So I'm going to multiply everything by negative 1. So I put everything in parentheses, and effectively what I'm going to do is multiply a negative 1 to every single term inside the parentheses. The practical outcome from doing that is that all the signs change. So instead of negative y, we have y. Negative 2x becomes 2x, plus 4 becomes minus 4. So, and the sign flips. So I'll write this little arrow and say y is greater than or equal to, because I flipped the sign, negative 1 times negative 2 gives me positive 2x. Negative 1 times 4 gives me negative 4. 2x minus 4. So y is greater than or equal to 2x minus 4. Now I have to graph that, okay, or sketch it. It does not have to be a work of art, ladies and gentlemen. It can just be a simple sketch. People are taking this way too far. Okay, so my y-intercept, remember, we're still in this y is greater than or equal to mx plus b. In this case, it's going to be minus b. So the y-intercept is negative 4. Let's go down here, put a little mark. And then I'm going up 2 over 1. Rise over run. Up 2 over 1. So go up 2. If this is negative 4, that's negative 3, negative 2, negative 1. So I make a little scale. This is y and this is x. And this is greater than or equal to, so I can put like colored in dots. A colored in dot is going to be greater than or equal to. If it had been just greater than or less than, and it didn't have this line, we would put an open dot. But we'll put in a closed dot right there. Now I'm going to go up 2 over 1. Up 2 over 1. Up 2 over 1. Like that. And now once I get a couple of them drawn in, I can draw it in. I'm going to shade in a solid line because this is greater than or equal to. Now because it's greater than or equal to, I'm going to shade above the line. So when you see greater than or equal to, you're going to be doing filled in dots, solid lines, okay, and the shading is going to be above the line, right? So our shading is going to be above the line. And that's what I want to see. I want to see that you basically have an idea of how to graph this, all right? So that's number 4. Number 5, what is the y-int of this? Now, little proviso, because that x is right there in the exponent position, I know that this is an exponential function. Exponential function. You got 3 types of functions in Algebra 1. Linear, quadratic, and exponential. Okay, this seems like the boss fight at the end of a level, but it's really the easiest one, really. Because the form that these equations take tells you everything you need to know. The form is, see if this orange shows up. Instead of f of x, I'm going to replace f of x with fv, meaning future value. Future value is equal to present value, PV, multiplied by 1 plus R, which stands for the growth rate. Sometimes it's the decay rate. Okay, and now this word of is going to be in my way, but raised to the, so this whole thing has this exponent of t for time, okay, or some other independent variable. So let's put that into practice. Let's go over here and show our work. If I was showing you a graph of this, in fact, why don't I show you a graph of this? You don't have to take my word for it. We'll talk to the calculator. I think I've got my emulator pulled up, so let me do this. Let me show the display and see if I can't pull up the emulator. There we go. Okay, so if you're looking at your calculator home plate here, hit Y equals, and we're going to type in what we saw there. We had 3, and then it was open parentheses, 1.12, close parentheses, and all of that was raised to the x. Okay, so now we're going to graph that and see what it looks like. All right, so I want to change my window a little bit here. I'll set the x minimum to 0 and the y minimum to 0. And what that's going to do is it's going to give us just quadrant 1 of the graph, which is what I want to see. And that looks more like what I'm looking for. Let me zoom out a little bit so you can see what happens to this curve. I'm going to have to reset the window. There we go. Now you see that exponential growth. Now, let's look at where this thing crosses the y-axis. 1, 2, 3. And if you don't believe me, go to your table. Second table. At x equals 0, y equals 3. So the y-intercept is 3. Right? Go back to your function. This was the present value in the exponential function. So that 3 is the y-intercept. Okay, another way to find that is to hit second trace and then hit intersect, which is 5. And it's going to ask you about the curve. Oh, I don't have two curves. Whoops. Never mind. Just use the tables. X equals 0, y equals 3. Let me flash back to the other screen. Okay. So here, you say 3 is the present value. And then I'll show a little tiny graph, this small. It really does not have to be a masterpiece. And then kind of a curve going off like that, and you put a little 3 right there. Say 3 is the y-intercept. Put that in a box. Number 6, find the solutions of x plus 3, x minus 2. All right. To find the solutions of factors, these two things are called factors. These are factors. Now I want to find what their solutions are. So I take the factors and I set each of the factors equal to 0. And I solve for x. So minus 3 on both sides and plus 2 on both sides for this second one. So in this first factor, x plus 3 equals 0, x equals negative 3. You're just solving for x. In the second factor, x equals positive 2. Something to look at. If you just have these simple binomial factors like this, you can just look at whatever the factor is. Like that's positive 3, so you know that the solution is negative 3. And here the factor says negative 2. The solution must be positive 2. It's always going to work out where you just flip the sign. But these are the factors. So that was a super fast problem. The only thing I want to mention here is that these factors are also where the x-intercepts are. And I just wanted to prove that real quick by showing you the graph. Oops. Okay. So I'll show you the graph. Don't need the PowerShell. Okay, let me clear this and put in open parentheses x plus 3, close parentheses, open parentheses, x minus 2, close parentheses. And let me just graph it. I got to get those window back to, let me just zoom standard. Okay, look at the x-intercepts, -1, -2, -3, so x is -3, and then here we're back to the origin, 1, 2. So the graph crosses the x-axis at -3 and +2. Glancing at the tables would show that. At -3, y is 0, so it's crossing the x-axis, and here at +2, y is also 0. Those are the solutions or zeros of the function, right? Let me get back to our table here. Okay, now we are on to number 7. Brian sells 3 pizzas and 5 hot dogs for $23. Casey sells 8 pizzas and 2 hot dogs for $50. How much does 1 pizza cost? How much does 1 hot dog cost? All right. You have to write while you read. This is a system of equations problem. So it's going to be something box. This is the template. Some people use this and some people don't. Something box plus something box equals something, and then below something box plus something box equals something. And we're just going to fill the table in now. This first row will be Brian, and the second row will be Casey. So Brian and Casey are the two people in this scenario. Brian sells 3 pizzas, 3, and then in the box we'll put P for pizzas, plus 5 hot dogs, H, for $23. Casey sells 8 pizzas and 2 hot dogs for $50. How much does 1 pizza cost? How much does 1 hot dog cost? Now, we could solve this using traditional elimination or substitution methods. But instead, what I want to do is use the calculator technique, what we call the matrix method. So what you want to do is make yourself a little 2-row, 3-column table and fill in these numbers in their positions. So here, 3 goes right here, and 5 goes right here, and 23 goes right here. Bottom row is 8, 2, and 50. Okay, so now we're going to go to the calculator and put this in to our matrix algorithm to find out how much a pizza costs and how much a hot dog costs. So we'll show the display again. And here we want to clear the memory. Second plus 7, 1, 2. Okay? Now, click on second. I want to clear this key press history. All right. I want you to see what keys I'm pressing here. Second matrix, right arrow, enter. And now it's a 2-row by a 3-column. So hit 2, enter, 3, enter. And you'll get this pop up like that. And now we're going to fill in the data that we have. We have 3, enter, 5, enter, 23, enter, 8, enter, 2, enter, 50, enter. Okay, so once we get it looking like our table that we drew, we hit second, quit. Then we hit second, matrix, right arrow, down, 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 until you get to option B, which is RREF, open parentheses. Click enter. Now hit second, matrix, enter, enter. And you get this little output table. And while you're looking at that, I'm going to write that down. 106011. And I'll flash back now to our paper. So these numbers are obviously the two important numbers that we want to know. And the best way I can explain this to students is this variable right here that's in that first position is going to correspond to that 1. So this top row is pizza. So 6 is pizza. And on the second row, the second thing is hot dogs. So this is hot dogs. What it means is pizza is $6 and hot dogs are $1. And this is the answer. Okay. Number 8. Solve. 8x to the 7th divided by 2x to the 5th equals 16 for x. It looks hard, but if we know our exponent rules, it really isn't. Now the first thing I want to do is I'm going to start working over here. The first thing I want to do is very clearly, let's just work on let me take those numbers and just separate them out mentally. I want to deal with these separately. So I'm going to divide 8 by 2 first. 8 divided by 2 is 4. Now I'll deal with these exponents here. X to the 7th divided by x to the 5th, we use the division rule or the quotient rule for exponents, and that's x to the 7 minus 5. So what's 7 minus 5? It's 2. So 4x squared equals 16. And now I'll move over here. So 4x squared equals 16. And I want to get x by itself. So because 4 is multiplied by x squared, I'll divide both sides by 4. And that will cancel out the 4 on the left side, leaving x squared by itself. And x squared equals 16 divided by 4. 16 divided by 4 is 4. And now, if I want to get rid of the x squared, I take the square root of both sides. And when I take the square root of both sides, let me just continue my problem up here. When I take the square root of both sides, I get x by itself on the left equal to plus or minus. Remember, when you take the square root of a number, you have to put plus or minus. And the square root of 4 is 2. So x equals plus or minus 2. And that is your answer. And put that in a box. Flip the page. If the initial temperature, this is number 9, if the initial temperature is 212 degrees Fahrenheit and the cooling rate is 23 degrees per minute, what is the temperature after 2 minutes. Well, the first thing we need to do when we show our work is actually set this thing up. Remember, future value is equal to present value times 1 plus r raised to the t for time. We just have to fill these things in. Future value. Now there's all kinds of synonyms, so we'll still keep with, we'll call this future temperature, since this is about temperature. Future temperature is equal to the initial temperature, which was 212 degrees, multiplied by 1 plus the rate. Now, what is the rate? This is a problem that you have to actually stop and hold up and think about. It says here the rate is 23 degrees per minute, but that word rate is being modified in this problem by the word cooling. So it's cooling off. If I'm drawing a picture of this, I want to show a declining graph. So I want to show something that's starting hot and getting cold, right? If this is temperature, if the y-axis is temperature and the x-axis, we'll see, temp, and the x-axis is time. So with respect to time, the temperature is dropping. This is called decay, exponential decay. So the rate of change is negative. So in R here, instead of R, we'll put plus negative. Now turn 23 degrees into a 23% into a decimal. 0.23. Okay. Close parentheses. Raised to the t. Well, how many times? 2 minutes. So put a 2 there. Well, now we kind of need to clean this up a little bit. It looks like a mess. Okay. 212 times. And now what is 1 plus negative 0.23? In the battle between plus and minus, minus always wins. So I'm really saying 1 minus 0.23. Squared. Okay, this can go in the calculator. So what we'll do is, let me switch it up a little bit. I'll use the physical calculator now, just so you get a sense of it. And here we'll leave it on the home screen and put in 212 times, open parentheses, 1 minus 0.23, close parentheses, little caret, squared. Right? Hit enter. 125.69. And I guess because we're talking about temperature, Fahrenheit, let's just round to, it doesn't say, so we'll just round to 2 digits. 125.69 degrees Fahrenheit. This is equal to 125.69 degrees Fahrenheit. And does that pass the smell test? Well, yes, because this temperature is less than the initial temperature. We would expect that if it's exponential decay, that the temperature would fall over time. So pretty interesting. After 2 minutes, the temperature of the water is 125 degrees. I have no idea if that is the real cooling rate of water, but I made it up for this problem. There we go. Okay, so it looks like we got another exponential function coming up. The starting salary is $15 per hour at Walmart distribution center. All right, so with this one, the salary increases. Okay, so rather than decreasing or cooling, it's increasing. So this is exponential growth. So this is going to be a growth function. The formula is FV, future value, equals present value times, open parentheses, 1 plus R, close parentheses, raised to the T. And I've got to fill in the values now. So our actual problem is like future salary, okay, is equal to the initial salary or the present salary or the starting salary, which is 15, times, open parentheses, 1, and it's growth because salary is growing over time. Now I got to figure out what to put for R. So R is going to be the growth rate as a decimal. So what is 2.5% as a decimal? Now I'm assuming that you know how to do this, but if you don't, you can put in 2.5 in your calculator and divide by 100. And it gives you 0.025. The other thing you could do is just put your pen on the decimal and move to the left 2 places, and you get 0.025. So 0.025, close parentheses, and then time. How long is the time? 9 years. So we put a 9 up here, and we're just going to compute that, right? So we'll compute it. 15 times, open parentheses, 1 plus 0.025, close parentheses, caret, just so you know what I'm saying when I'm saying caret, it's that button, right? Like some people call it house, some people call it caret. And then put 9 in the exponent position. Hit enter. 18.73, this is money, so it's $18.73 an hour. $18.73 per hour after 9 years. Okay, so we'll put that in a box. And unlike the one above, this is exponential growth. So if I'm going to do a little tiny graph, goes up like that instead of down. Number 11 is -7/2, 3 in the solution set of this linear inequality. Well, the first thing we have to do is get the linear inequality where y is by itself on the left, and then we can actually work on it. So over here I'm going to start by rewriting 2 minus y greater than 4x plus 9. Okay, so I'm going to solve for y. My first step is to subtract 2 from both sides. On the left, those cancel, and I've got negative y greater than 4x, and then 9 minus 2 plus 7. 9 minus 2 is 7. Now, I'm going to multiply every term in the inequality by -1. And the reason I'm doing that is I want to get rid of that negative sign. So I'm going to distribute that -1 to every term. And in doing so, I'll have to flip that inequality symbol. So we'll take our equation up here. And I've got positive y, because -1 times negative y is positive y. And then flip the sign. So it used to be greater than, now it's less than. -1 times 4x is -4x. -1 times 7 is -7. So I'm looking at graphing that, and I want to find out if something is in the solution set of it. So I need to graph it. Okay, again, this is not, it does not have to be a work of art. It's really just, it's like a sketch. So I know the y-intercept of this inequality is -7, and because it's less than, there's no little bar underneath that. I'm going to put an open circle at what I think -7 is going to be, right there. And now my slope is -4. Rather than going down 4 over 1 because it's negative, so the rise is really a fall, I'm going to go up 4 and then to the left 1. It has the same effect as going down and to the right. I can go up and to the left. Okay, kind of like Tetris. So we'll just mark this out. There's your scale. And so I'll go from negative 7. This is 0. I got to go up 4 and then to the left 1. So it's like a little bit more than halfway up and to the left 1. So here's my inequality. It's going to be a dashed line. And it's going to look something like that. And the question is it shaded above the line or below the line? It's shaded below the line. Okay. And what I want to know is whether this coordinate is in the solution set, negative 7 over 2, comma 3. Well, negative 7 over 2 as a decimal, you know, if you didn't know, you could hit negative 7 divided by 2. Oops. Divided by 2, and you would get negative 3.5. So negative 3.5 comma 3. Where would that be? Is that going to be in our solution set? Negative 3.5 comma 3. Well, no, it isn't, because that's going to be somewhere over here. That point's going to be like right there. Right there. And that is not in the solution set. So the answer to the question is no. Got to show the work. Okay. Now we're going to simplify this. And we're going to use the quotient rule. Now the first thing we're going to do to make this easier on ourselves is remember that letters that are by themselves have an unwritten exponent of 1. So in the denominator, we'll start by putting 1s there so we don't make silly mistakes. Now let's group. So I know when I divide, I subtract the exponents. When I divide, I subtract the exponents. So that would be a to the 7, and look in the denominator. I got a to the 1, so a to the 7 minus 1 equals a to the 6. And then I've got b to the 5 minus 1, because that's a 1, equals b to the 4. And c is all by itself in the denominator. So in the numerator, I have a to the 6 times b to the 4. And in the denominator, I have c. So that's the simplified expression. No problem there. Number 13, simplified. This is the power rule. So what I got to remember about the power rule is that I multiply the exponents. So this is equal to x to the 2 times 4, which is equal to x to the 6. That's the numerator. The denominator is using the product rule. So when you have bases that are the same, you add the exponents. So I've got x to the, let me put this whole thing, x to the 1 plus 7. Okay, 1 plus 7 is x to the 8. I made a mistake right there. Sorry about that. I said 2 times 4 and then I wrote 6 like an idiot. Okay. Should be an 8. My bad. Okay. So now I've got x to the 8 over x to the 8. X to the 8 over x to the 8. And I can just see that I have something divided by itself. So something divided by itself is 1. So I already know this is 1. But if I wanted to prove it, I could use the 0 exponent rule by saying x to the 8 minus 8 equals x to the 0. And according to the 0 exponent rule, anything raised to the 0th power is 1. So x to the 0 equals 1. And this is the work. But this is the answer. 1. And I'm really sorry about that mistake there. I wonder if I could crop it out of the video. But I don't feel like editing it, so probably not. Now I'm going to factor this, and we're going to factor this by hand. And remember, we have this little trick. So my little trick is I need 2 numbers that add to give me the middle term, which is 5, and that multiply to give me the last term, which is negative 14. So I got to think about my factors of negative 14. And I've got 2 times negative 7. But 2 plus negative 7 is negative 5. I wanted positive 5. I've also got negative 2 times positive 7. So those work because negative 2 plus 7 is 5. So my factors are negative 2 and 7. Negative 2 and 7. Negative 2 plus 7 is 5. Negative 2 times 7 is negative 14. So the way I write those factors is I'm going to put open parentheses, close parentheses, open parentheses, close parentheses, x and x. And then I've got minus 2 and plus 7. Okay? So those are your factors. And that's the answer to that. Number 15, simplify. 18x squared minus 9x, all in parentheses. These parentheses turn out to be very important. Like this is kind of the giveaway that they're going to do something with those. Over 9x. So because I got parentheses, my brain is being triggered. PEMDAS, parentheses, I better do something here. Is there a factor that I can pull out of both of these terms? What can I pull out of both of these terms? Well, I could pull out a 9 because 18 can be divided by 9 and 9 can be divided by 9. But is that the greatest common factor? And this is something that we should probably do more examples of. But I can also pull out an x. See, because I've got an x squared here and an x here. So I can pull out a 9 and an x. So I pull out a 9. Cancel, cancel. And 18 divided by 9 is 2, so there's a 2 left there. And then I'm also going to pull out an x. Right? So I'm left with x minus 1 on top, and I pull out an x. This got real messy over here, so I'll show that again. I have 18x squared minus 9x. I want to factor this, I want to pull a common factor out. So what I'm going to do is divide both of these terms by 9x. And that maybe makes it a little bit clearer. So here, those cancel out, leaving behind a 1 in their place, not a 0, a 1. And here, these cancel out sort of, leaving behind a 2 on top and an x. So this is 2x. And I pull outside 9x. So I've got 9x, open parentheses, 2x minus 1, close parentheses, all over 9x. Now, the quick observer will notice that I can cancel out these 9x's, leaving behind 2x minus 1. So this whole thing can simplify to 2x minus 1. And that will go in a box. And that is the simplified there. Okay, number 16. What is the domain? All right. Keyword right here, domain. The domain of a quadratic function is all real numbers, unless otherwise specified. But we have to learn how to write that in the language of inequalities. So I write negative infinity less than or equal to x, because I'm looking for the domain, and the domain refers to x values, less than or equal to positive infinity. This is the domain. Now the range, because this is your teacher here, I'm going to show you the range since we're here. Let's talk about the range. The range has an upper limit of 4. So I'm going to go and put a 4 here. Okay, and work kind of backwards. Negative infinity. So the range is negative infinity all the way up to 4. That's domain and range. Okay, number 17, the equation of a line parallel. So I'm already stopping because I've come across an important word. Parallel. Parallel means same slope. Think about parallel lines. Here's a fake graph. There's parallel lines. They're going to have the same slope, just different y-intercepts. Okay, so equation of a line parallel to this equation, passing through 0, 6. Now I'm triggered here by this 0, 6, because when I see x is 0, this y value must be the y-intercept. So this is the y-intercept. All right, so I'm going to have this. I already know the y-intercept. Now look, the equation of my line, y equals mx plus b, I can already fill it out because I know the y-intercept, which is the b value, that's 6, and I know the m from the original equation because it's going to have the same slope since it's parallel. So y equals 7x plus 6 is going to be the equation of the line parallel. Put that in a box. Okay. This whole thing was the thing to box up in the other problem right there. Number 18, equation of a line perpendicular and then passing through a given point. Okay, and again, here they're having it pass through the y-intercept. So it's always good to make a note that we now know that 5 is the y-intercept of the new line. So first we have to get this line into y equals form so I know what the slope is that I need to take the negative reciprocal of. Because now I'm dealing with a perpendicular situation. So I'm given a slope, and I've got to take the negative reciprocal of that slope, and then I've got the equation, I've got the slope of the perpendicular line, and I already know the b value. So let me just solve for y right here. We got I got 15x minus 3y equals 75. Okay, so I'll subtract 15x from both sides, right? And then I'm going to make a little bit more room. I have negative 3y equals, and put the negative 15x up front, negative 15x plus 75. Okay, and now I have to divide every term by negative 3 to get rid of that negative 3. And so I have, those cancel out. I have y equals negative 15 divided by negative 3 is positive 5. Y equals 5x. And then 75 divided by negative 3 is minus 25. So my equation of my line is 5x minus 25. I had to convert from standard form to slope-intercept form. So now that I've got this, I can find the equation of the line perpendicular. Okay, so I've got some extra space up here. I'm going to use the space from this problem to help me. So if m equals 5, then negative m to the negative 1, or the negative reciprocal slope, is negative 1 over 5. All right, so I already know the b value of this line. I've got the perpendicular line, so like y perpendicular, that's a little perpendicular symbol, equals negative 1/5 x plus 5. All right, and that is the equation of the line perpendicular passing through 0, 5. And finally, number 19, in a sequence defined by f of x equals 8x plus 3, what is the seventh term? Show work. All right, so what it's really asking is f of 7. Just so you know, like what we're doing. That's 8 times 7 plus 3. So 8 times 7 is 56 plus 3, 56, 57, 58, 59. So this is equal to 59. Now, if you didn't know how to do that, you could just turn on your calculator and go to y equals, and then put this in, the function you're given, 8x plus 3, 8x plus 3. And then go to the graph, or the tables, and go down to where x is 7, and you'll see that y is 59. So that's how we know that one. Okay. Sorry the video ran twice as long as I anticipated, but try to work through them and make sure you understand not just what the answers are, but how to get them. So please understand this, that this video is, and the paper that you're working on, this is identical to the actual test in its form. I've basically just changed the numbers around, and changed the situations a little bit. But if you study this and you work through this, and in class tomorrow, please feel free to ask for another copy of this so you can go home and work it again. When you take the test on Monday, you will be ready. I promise you that. There's no surprises. Okay, just remember your rules, take your time, and make sure you go over this and show all your work. All right. I hope this was helpful. Thank you.